Hello everyone, I'm Shu Yue from Xi'an University. I'm honored today to present a work of our team, Automated Bug Reproduction from User Reviews for Android Applications. My presentation will be around the following sections. The first one is motivation. Mobile application users may not download the app when they see the negative user reviews, especially bug-related ones. Meanwhile, the bug can largely influence the user experience. For these two reasons, the app developers must fix the bugs mentioned in user reviews as soon as possible. And the very first step is bug reproduction. So, we expect to relieve developers from this time-consuming task and with some automated approach. It sounds useful, but the question is, how? First of all, we inspect more than 3,000 bug-related reviews from Google Play, and we find out two major challenges of automated bug reproduction from user reviews. The first one is that user reviews are noisy, so extracting useful information from user reviews is quite challenging. Secondly, it is also difficult to leverage limited information to reproduce bugs. I will show two examples. The noise in user review includes misspelling, repetitive words, and some unrelated information about bugs, such as users' complaints, suggestions, and other topics. But the information for bug reproduction is very limited. In our dataset, rare user reviews specify the device and the Android operation system version on which the app runs, and the user only provides some incomplete information about the bug. For example, they tend to describe the last action that they take or the last state of the app before a crash happens. To solve these challenges, we design our approach and implement a tool named Reproduction. There are two phases in our approach: user review processing and guided search. In user review processing, we aim to extract information from the original user review, and we identify two kinds of information for bug reproduction. The first one is functionality description. We find that these words frequently appear in an app's user reviews, but rarely occur in the other app's user reviews. So we design token frequency analysis to extract these kinds of words. The second kind is GUI actions and GUI components. We find that users tend to describe GUI events with two grammar patterns: verb object structure and passive nominal subject structure. So we use dependency parsing to extract these words. These two kinds of words are merged and will serve as guidance in the next phase. In the second phase, we guide the search at each step with information from user reviews. We adopt the depth-first search strategy, which is widely used in Android testing. The GUI space is huge, so we design two techniques for efficiency. First, at each step during testing, we rank GUI components by user review. We have two observations here. GUI components are short, and different components in an app share many same words, so their similarities to user review are usually close. At the same time, there is a lexical gap between user reviews and the GUI components. So we combine word embedding and frequency analysis to measure the similarity. Secondly, we encounter many circumstances where The scores of GUI components on current screen are all zeros, so our search will degenerate to random search. We don't want to randomly choose one component, so we design a technique named one-step exploration to enhance the information of a GUI component by the screen triggered by interaction with it. For example, the left screen in this picture has no similarity with the user review, but after clicking this button, the new screen on the right provides some new information and has high similarity with user review. So we can confidently click this button at this point now. And by the way, we choose one step rather than two or more steps here for efficiency, since we need to restore the original screen after one-step exploration. To evaluate our approach, we have 3 research questions to answer. For the first one, we collect the user reviews from 17 popular apps from Google Play, and our tool has about 70% success rate. For the second research question, we compare the time of our tool with our human. The average time of our tool is longer than that of a human, but is still acceptable. And we find that humans also spend more time on the crashes that our tool fails to reproduce. It may suggest the difficulty on these user reviews. For the last research question, we evaluate the effectiveness of 2 major techniques of our approach: one-step exploration and user review processing. The results show that they are both useful to improve search efficiency. We also studied the failure cases of our tool. I will not explain them all due to the time limit. I only show one example here. One major failure cause of a tool is the lack of comprehension of natural language. The user review here says it crashes if you have more than 4 levels of sub-account. This description cannot directly link to any GUI actions, so our tool failed to reproduce. To summarize, we present a bug reproduction tool from user reviews on Android platform, and the experimental results show its efficiency. We hope this tool can help more app developers or testers in practice. That's all of my report. Thank you.